All right, welcome to your next lab. This one is all about trees, not BSTs, just trees. And we're going to do a million little recursive algorithms on them. So if you're not comfortable with recursion yet, I'm going to force you to get very, very comfortable with it. So prepare for that. Get the starter code, and then the trees that will be used in this lab are what are known as expression trees. So you can imagine, and hopefully it's not too hard to go from an arithmetic expression like this to the following tree. Like on the outer level you have a subtraction, that's the last thing that you do. So it's minus all this stuff on the left over here, and then this 9 on the right. All right, and so then inside of here on the left subtree, you've got at the outer level a plus operation happening. Plus with 2 on the left, and then 7 times 8 on the right, and I think you get the idea now. Okay, so every operator, it's an interior node, or an internal node. It's not a leaf, and every leaf holds a number. Okay, so operators are not leaves, but leaves are. Okay, so that is a valid expression tree, and you can imagine that there are many such trees. So let me open up expressions.h. Dun, dun, dun. So this is the type of tree node. So I'm going to give you a pointer to the root of this kind of tree, and it's going to be an expression node. That's going to be the root. So root, root, root. And at every node, you can go left or right, and just for consistency's sake, I should put the star over there. There we go. And if it is a leaf, there will be a data value that you should look at. If it is not a leaf, there will be an op character. Okay, so up here, it's not a leaf, it's a minus, so the op will be set to the minus character, the dash. But down here, data will be set. Okay, and if you go to my tests, you can see me make a bunch of different little test trees. Way down here. So here is a simple tree for 2 plus 3 times 5, and you can see how I'm making these nodes. I'm setting the operators for the non-leaf nodes, and I'm setting the data for the leaf nodes. So you need to know which is which so that you know what to get out, what to extract. And then I'm building up the tree and returning back the tree for one of the tests. So I'm going to use empty trees in my tests, this little simple tree, and then also this monster of a tree. Okay? So hopefully my drawing is understandable, and you can use that to help you write this stuff. Okay, so the next thing is all the stuff that you're going to be writing. So the first recursive function you'll write is a recursive expression evaluation. So given one of these trees, do the operations that are specified and actually get an answer out of this. So this is supposed to be 2 plus 3, then add 4. Okay, so the answer is 9, and you're supposed to get that recursively. So I'm going to give you the root of a tree, and I want you to calculate the integer result based on that. Let's see. Yeah, I think these are all essentially the same. So implement this recursively. And so, as a hint, the recursive case should correctly come up with 5 for this left subtree, and correctly come up with 4 for this right subtree. And it's your job to see that there's a plus operation at the root and add them together. Okay? And as a hint for your base case, every leaf, when you see one, it's just a single number, and that's the result, right? 4 is 4. There's nothing else to do. So there's a recursive case for you and a base case for you. Hopefully that's enough to get started. And then you'll work on all these traversals. You got your pre-order, your post-order, your in-order, and your breadth first. And so I want you to take one of these trees and calculate a string based on it. So for example, if I gave you this string here and I told you to do an in-order traversal, if I gave you this tree here and I wanted you to do an in-order traversal, you should recursively calculate the strings of the left and right subtrees. So you get 2 plus 3 and a 4 over here, and then just put them together with the operation that was in between them. Okay, so that's an in-order traversal, and you'll do very similar things for the rest. post, pre, in order, and breadth first. And here is an example of what it will look like. So for the simple tree that I defined down there and showed you before, your function should calculate the following string. Okay, so that's how I'm comparing things, and this shouldn't be too horrible to see what it's supposed to be, at least. But if you don't have a lot of experience with recursion, now's the time to get experienced. All of these functions are going to be recursive. Then you're going to calculate the height of a tree, okay? And the way you're going to do that is, again, using the recursive cases and the base cases. So the height of a tree is the longest number of edges from the root to a leaf node. So for this example, the lowest nodes are down here, the 2 and the 3. So you're going to have to figure out that, okay, the left subtree, if I look at that only, and I get the height of that, that has height 1 if I just look at the left subtree. And the right subtree has height 0. Well, at my node, from my point of view, from the original node, there's one more edge. So I'm going to add that, and notice that the height of the whole tree is 2. Okay, so there's like a maximum calculation going on here. And then one thing to keep in mind is that the height of a empty tree is -1. I think I test that somewhere. Dun, dun, dun. Yeah, so as long as you use that as your base case, that will solve everything. Okay, and then the final recursive function that you'll write, you're not going to write any tests. I've written them all. You just write these recursive functions. Get used to recursion. The final one is, you can call it reverse or mirror. It might be easier to think about it as mirroring, but the name of the function is reverse. Sorry. So given this tree again, to reverse it, you'll flip all the left and right subtrees. So for example, at this node, I'm going to recursively flip the left subtree and get back 3 and 2 and plus, because it flipped them. Flip the 3, put the 3 on the left and the 2 on the right. And then it's going to recursively flip this 4 subtree, which is just going to be 4 again. And then it's going to swap their places. So now the 4 is on the left and the reversed subtree is on the right. Okay, so hopefully you can see what needs to happen there in terms of recursion and base cases. And the one thing about this function is it's void. So you're going to modify the tree that was given to you. Okay, so at the end of the day, you're going to have swapped around all the pointers in that tree itself. You're not going to make a copy or anything. Okay, so just compile my test file, get all the tests to pass. You don't have to make any of your own, and that's all you have to do this week. Okay, so this is just getting comfortable with trees and getting extra comfortable with recursion if that's something that scares you still. So please yell at me if you have any questions, and I think that's all. I'll turn in that one file that's your implementations. Okay, so I think that's all I wanted to say, and I will see you in the next one.